All right, let's talk about something we almost never think about. We see these giant skyscrapers, massive bridges, sprawling cities, and we just assume the ground underneath them is solid as a rock. But what if I told you the ground beneath our feet is in a constant state of slow-motion compression? Today, we're going to pull back the curtain on the hidden science of why buildings sink, a process known as soil settlement.
So, here's the game plan. We'll kick things off by framing the problem with a really simple analogy. Then, we'll get into what soil settlement actually is before breaking it down into its three main parts: the instant shift, the slow squeeze, and that mysterious creep. And finally, we'll see why all of this is so incredibly critical for everything we build. Okay, so how do you even wrap your head around something like the entire ground compressing? It sounds huge, right? Well, let's start with a super simple idea. I mean, have you ever wondered why buildings or roads get those little cracks over time? Or why a bridge might look like it's tilting just a tiny bit? You've definitely seen it, right? A crack in a wall, a sidewalk that's all uneven. It's easy to just brush it off as old age, but nope. It's often a sign of something much bigger happening, silently, right under our feet. The easiest way to picture this is to think of the ground less like solid rock and more like a giant super firm pillow. Now, what happens when you put something heavy on a pillow? It squishes down, right? The same thing happens with a building. Its immense weight compresses that ground pillow, making it sink just a little bit. And that slow-motion sinking, that's what engineers call settlement. Okay, so the pillow analogy is a great start. But let's get a little more scientific. What's really happening down there in the dirt?
So, soil isn't one solid thing. It's actually a mix of tiny particles. Think sand, silt, clay, with little empty spaces in between them. Engineers call these voids. And these voids are filled with either air or water. So when we talk about settlement, all we're really talking about is the process of squeezing those voids shut, pushing the particles closer together, and basically making the soil more compact.
And this squeezing, it can be kicked off by all sorts of things. You've got natural causes like erosion or even just changes in the groundwater. But really, what we're zeroing in on today are the things we do. The massive, incredible weight of our buildings, our roads, all that traffic. The whole process of urbanization just puts this constant, heavy pressure on the ground. Now, here's where it gets cool. Engineers have basically broken this whole process down into a three-act play. You've got Act 1, the instant shift, Act 2, the slow squeeze, and the finale, the mysterious creep. And trust me, understanding these three acts is absolutely crucial if you want to build anything that lasts. All right, let's dive into Act 1, the instant shift. As the name suggests, this happens right away. It's the soil's immediate reaction. Think about it like this. If you pour a bunch of marbles into a jar and give it a little shake, what happens? They all settle and pack in tighter, right? That's pretty much what's going on here. The second you put the weight of a building on the ground, it forces those little soil particles to just shuffle around and find a cozier, more packed-in arrangement. It's the soil's instant reaction to all that new pressure. But here's the catch. Not all ground is created equal. If you're building on something like a loose clay, well, those tiny particles can shift around really easily. That means you're going to see a lot more of this immediate settlement. But if you're on dense sand, those particles are already pretty jammed together, so there's not much room for them to move. They experience way less of this instant shift. So the big takeaway here, the type of dirt you're on matters a lot, right from the get-go. Okay, on to Act 2. And honestly, this is the main event. This is the big one. It's called consolidation settlement. And this is where things get really, really interesting. Why? Because this part of the story is all about water.
Grab a wet sponge in your mind. When you first push down on it, it gives a little. But the real compression, the big squeeze, happens as you force all that water out. That's a perfect analogy for what's happening in the ground. For soil that's full of water, what we call saturated soil, the weight of a new building puts a ton of pressure on all that trapped water.
There's a fancy term for this, excess pore water pressure. And what it means is that for a little while, the water trapped in those tiny voids is literally holding up the entire building. The soil particles themselves can't get any closer together, not until that water gets squeezed out and has somewhere to escape to. And that's the key. The water has to drain away. But in soils like clay, where the particles are super fine, it's like trying to squeeze water through a coffee filter that's way too dense. It happens, but it is incredibly slow. We're talking months, sometimes even years, for all that water to finally escape. And only then can the soil particles actually take on the load and finish settling.
And just look at how big of a deal this is. When you're talking about those wet, fine-grained soils, consolidation isn't just part of the story, it is the story. It can be responsible for 70%, sometimes even more, of the total sinking that a building will ever go through. This is, without a doubt, the #1 thing engineers have to get right.
So, okay, the particles have done their initial shift. All the water has been slowly squeezed out. The show's over, right? Nope, not quite. That brings us to our third and final act, the one they call the mysterious creep. And it's called mysterious for a reason. Even the experts will tell you this is the slowest and the least understood of all the types of settlement. It's this weird phenomenon that just keeps going, long after you'd think everything should have stopped moving.
So what in the world is going on? Well, think about it. That building is sitting there putting pressure on the ground 24/7 for decades. And over that long time, the actual soil particles themselves can start to slowly change shape. They deform. It's a process called plastic deformation. They kind of squish and shift into even tighter arrangements. It's super subtle, but it's happening, and it's absolutely relentless.
Okay, so there you have it, our 3-act play. The instant shift, the slow squeeze, and the mysterious creep. So why do we care? Why does getting this all right matter so much?
Because this is the entire ballgame for a geotechnical engineer. They have to be like soil fortune tellers. Their job is to predict not just how much a foundation will sink, but also how fast it's going to happen. And when you're talking about massive projects, dams, bridges, skyscrapers, getting that prediction wrong, well, that's how you get cracks, distortions, or even total structural failure. Understanding this hidden science is literally what keeps our modern world standing.
So, the next time you're looking at a big city skyline, just remember, every single one of those buildings is locked in this slow, calculated dance with the ground beneath it. And that kind of leaves you with this one big question, right? In a world where we're constantly pushing the limits, building bigger and taller, what does it really mean to build for the future on a planet that never ever stops moving?